Okay, we're going to look at a couple multi-step problems here. The first one says how many square feet are in an area of 1 square meters. So we're going to start with 1.00 meters squared. Put that over 1. I want to go from meters squared to feet squared, and I'm given the appropriate conversion factors. So I've got 1 meter equals 39.37 inches. So I need to cancel meters, so that's going to go down here. The 39.37 inches goes up here. Now, meter squared does not cancel with meters. Meter squared is a meter times a meter. So what I have to do is actually write that step one more time, because a meter times a meter at the bottom would equal a meter squared. Now if I stop, I have inches squared, but I want feet squared, so I'm going to keep going. Inches down here at the bottom, and there are 12 inches in a foot. And just like before, that's only going to cancel one of those, so I need to write that equality conversion factor once more to cancel that second inch. Now I have feet squared in the numerator, so now I can solve. Just multiply straight across, divide. I do need to pay attention to significant figures. 1.00, that's what I started with, has 3 sig figs. 39.37 inches in a meter. Well, that's a conversion factor. That's a defined quantity, so that's infinite. And then 1 foot in 12 inches, that is also a defined quantity. So I start off with 3 sig figs. My only measurement was 1.00 square meters. I have to end up with 3 sig figs. So you get an answer of 10.764, but we need 2. Round that to sig figs. That would not be correct. 10.764 would round to 3 sig figs. It would be 10.8. So pay attention to sig figs as we go through these problems. Next problem, complex units. Gold has a density of 19.3 grams per centimeter cubed. So we're going to start there. 19.3 grams. We're going to put centimeter cubed in the denominator. So the units are going to be set up like that. We want the density in kilograms per cubic meter. We want to end up with units of kilograms on top and meter cubed on bottom. So we're changing both the top and bottom units. I'll change the top first and go from grams. I want to change it to kilograms. That's a prefix. Put the 1 in front of the prefix. And kilo, what does it mean? That goes down here. Kilo is 1 times 10 to the third, which is 1,000. That's going to get rid of grams. My numerator is good. I will have kilograms. I need to change the denominator to cubic meter. So centimeters, even though it's way over here, it will still cancel top and bottom if I put centimeters on the top. And I can go to meter. That's another prefix. You put the 1 in front of the prefix and you put what it means at the bottom. Centi is 10 to the negative 2. Now this is centimeter cubed over here, so this equality, in order to get centimeter cubed, actually has to be written 2 more times. Same equality, just write it twice more. Centimeter times centimeter times centimeter gives you centimeter cubed, and that will cancel out. My units, the only ones I have left, kilogram, meter, cubed. Sig figs, 19.3. I start off with 3 sig figs. Prefixes are unlimited. They're defined quantities. So everything else is an infinite number of sig figs. So if I start off with 3 sig figs, I end up with 3 sig figs. As you do the math, and again, make sure you can get these answers that I'm getting in your calculators. But that's a complex unit. Units on top and bottom had to be changed in order to get to kilograms per cubic meter in this case. Okay, one more here. There's 7 times 10 to the 6 red blood cells in 1 millimeter cubed of blood. How many red blood cells are in 1 liter? I don't want to start with 7 times 10 to the 6. That's an equality. That equals 1 millimeter cubed. I want to start with 1 liter. Somehow I need to get from liters, that's a unit of volume, to millimeters cubed, which is also a unit of volume, by the way. So I'm going to start with liters. I'm going to go to millimeters cubed. Well, I can go from liters to milliliters. Milli is a prefix, put a 1 there. That's 10 to the negative 3. Sorry, that's a negative 3 there. That'll cancel out liters. Told you there's one conversion factor you need to know. 1 millimeter is equal to 1 cubic centimeter. Cancel out units as I go. Now I've got centimeters cubed, but I want millimeters cubed in order to use that conversion. So I need to go from centimeters cubed back to my base unit, which is meter. Centi is 10 to the negative 2, so that's 1 times 10 to the negative 2 meters in 1 centimeter. Now this is centimeter cubed on the top. In order to cancel this, I need to actually write that 3 times. So we'll go ahead and write it a couple more times. That will cancel out the centimeter cubed. We're going to continue down here. So this is a continued problem. It's kind of long. I've got meters cubed at the top. Well, I need to get to millimeters cubed. So meters is going to go on the bottom. I can go from that base unit meters to millimeters. Put the 1 in front of milli. Milli means 10 to the negative 3. But just like we did before, that equality is going to have to be written 3 times total. That will cancel out the meters cubed. Now I have millimeters cubed. I'm trying to get to red blood cells, by the way. There are 7 times 10 to the 6 red blood cells in 1.0 millimeters cubed. Finally, toward the end, 1 millimeter cubed is equal to 7.0 times 10 to the 6th red blood cells. Millimeters cubed cancel. And I'm finally there at red blood cells. Significant figure-wise, I start off with 1.0 liters. That has 2 sig figs. Everything else is a conversion factor up until the 7.0 and the 1.0 back here, which also have 2 sig figs. So my answer should have 2 significant figures. And this is one where I would suggest going through the math, making sure you get the right answer. But in order to get 2 sig figs, it's going to be 7.0 times 10 to the 12th red blood cells.